download our Revise It Right revision app for hundreds of videos, quizzes, exam questions, tutor support and so much more. This video is about electrolysis of solutions. Now we've looked in previous videos that for a ionic compound to be electrolyzed, it needs to either be molten, i.e. liquid, which we looked at in the last video, or it needs to be dissolved in a solution, which we're going to look at in this video. Now it's a little bit more complicated, so please make sure you are paying attention. Okay, now if an ionic compound is soluble, then we can electrolyze its solution as the ions become free to travel through the water. So what we're going to do is we're going to take sodium chloride as an example. Okay, so we're going to dissolve sodium chloride in water. Okay, now in water you have H plus ions and you have OH minus ions. And that's obviously where our H2, so our two H's and O, that's where our water comes from. H plus ions and OH minus ions. So when we dissolve our sodium chloride, our sodium is going to become plus ions and our chlorine is going to become the negative ions. So now we've got two lots of each. We've got two positive ions in there and we've got two negative ions in there. Okay, we're going to electrolyze this. So we're going to have our positive anode and our negative cathode joined together by a power supply. Okay, now as I just said, we've got two positive ions and two negative ions. So how do we know which positive ion is going to form at the cathode and which negative ion is going to form at the anode? Well, for us to understand that, we need to learn some rules. Okay, some two rules that we need to learn. Okay, so let's start with the anode. Okay, so let's start with the anode. Now at the anode, we know our negative ions are going to want to form there. Now the rule that we need to know for our anode is if the non-metal, i.e. our negative ion, i.e. our chlorine, is a halogen. Now halogen means it's in group 7, the halogen will form at the anode. Okay, if it is not a halogen, i.e. if it's not in group 7, it's not a halogen, then oxygen will be produced at the anode. Okay, so that's quite a long rule to get your head around and I'll apply it in a second. But if the non-metal is a halogen, i.e. if it's in group 7, the halogen will form. If it is not in group 7, then oxygen will form at the anode. So that's our rule that we need to learn about with our anode. Now there's also a rule for our cathode to tell us which positive ion will form. Okay, so the rule that we need to be aware about, if the metal, so the positive ion, is more reactive, if the metal is more reactive than hydrogen, hydrogen will form. If it is less reactive, then the metal will form at the cathode. And again, another long rule to get your head around, but I'm going to apply it now. Okay, so we've got here, as I've drawn, we've got two negative ions. We've got chlorine and we've got OH minus. Now we need to know which one is going to form at the positive anode. So we need to follow this rule here. So if the non-metal is a halogen, the halogen will form. So what we need to do is we need to look at the non-metal, which is chlorine, and we need to see if it's a halogen. We can do that by going to the periodic table. Chlorine is in group 7, therefore chlorine is a halogen. So what that means is the halogen will form at the anode. So chlorine will form at the anode because it's a halogen. Okay, so at the anode, chlorine gas will have formed. Whereas at the cathode, we need to follow this rule. So again, we've got two, we've got sodium and we've got hydrogen. We need to know which one's going to form. If the metal is more reactive than hydrogen, hydrogen will form. So to do this, we need to go to our reactivity series and we need to look at sodium and hydrogen. Sodium is more reactive than hydrogen. It is more reactive. And if we go back to our rule, that means that hydrogen will form. Okay, so because sodium is more reactive than hydrogen, hydrogen will be the one to form at the cathode. And that is our rule. Okay, that is the rule we need to follow. So we know which forms at the anode and which forms at the cathode by following these rules here. So if we then want to write our half equations, which we looked at in the previous video, so if you don't know how to do these, then please go back and watch that. At the anode, we've got chlorine ion, which is going to lose an electron to become chlorine. So it's going to lose that electron. Have a chlorine never exist on its own, so it's chlorine 2. So therefore 2 electrons lost and we need 2 chlorine. So that will be the half equation at the anode. And at the cathode, we've got hydrogen being formed. Okay, so hydrogen, the H plus ion, is going to gain an electron to become hydrogen. But hydrogen always exists in pairs, so H2, therefore need 2 hydrogen ions, 2 electrons. So that there is our half equation at the cathode. Remember to download our Revise It Right revision app, watch over 700 videos, answer 4,000 plus quiz questions, over 1,000 flashcards, 1,000 exam questions, worksheets, forums, and get help from qualified teachers and so much more. The link is in the description. So because that is quite a difficult concept to get our head around, I'm going to do a couple more examples. So here we've got copper sulfate and we've dissolved it in water. So therefore we've got the copper plus ions and the H plus ions, which could form at the cathode. Okay, and we've also got our sulfate ions, which are negative, and our OH minus, which are negative, which could form at the anode. Okay, so we'll start with the anode. Okay, remember that the rule at the anode is if the non-metal is a halogen, then the halogen will be produced. If it is not a halogen, then oxygen will be produced. Okay, so we need to look at our sulfate ion. Sulfate is not a halogen, and therefore oxygen will be produced. Okay, so this here is not a halogen, so the rule says therefore that oxygen will be produced at the anode. Okay, so oxygen will be produced at the anode. Now our half equation for this is our OH minus, okay, will form oxygen gas, but that also leaves over the hydrogen, and this will form H2O, okay, which is a liquid, and because of that it will lose electrons. Now we just need to balance this out to know how much electrons it loses. Okay, so that would be that and that would be that there, and therefore it's going to lose 4 electrons. So that is our half equation for oxygen at the anode. Now this doesn't change, so it would be a good idea to learn this half equation for oxygen, just in case your exam question is oxygen is produced at the anode. So we know that the oxygen is produced at the anode because sulfate ion is not a halide, and therefore oxygen is produced. So now we're going to go to our cathode. Now remember the rule is if the metal is more reactive than hydrogen, hydrogen will be produced. If the metal is less reactive than hydrogen, then the metal will be produced. Okay, so we need to look at our reactivity series. Copper is less reactive than hydrogen in our reactivity series, and that means that copper will be produced. Okay, so copper will be the one that is produced at the cathode because it is less reactive than hydrogen. And we need to do our half equation for that. So copper 2 plus is going to gain 2 electrons to become copper. Okay, and that is our half equation for our cathode. So I'm going to go through one more example and then I'm going to give you a chance to have a go at your own. So we're going to do calcium nitrate. So you can see here we've got the calcium ions, they're positive because it's a metal, and then we've got the H plus ions from the water, and then we've got the nitrate ions which are non-metal and therefore negative, and we've got the OH minus ions as well. So we first need to decide which is going to be produced at the positive anode. Is it going to be OH minus or oxygen, or is it going to be the NO3 minus, so the nitrate? Okay, so the rule is if it's a halogen, then it will be the halogen. If it's not a halogen, it will be oxygen. So nitrate ion is not in group 7, therefore it's not a halogen. That means oxygen will be produced at the anode. Okay, and we've just looked at our half equation for oxygen. Let's go through it again. So we've got the OH minus, which is obviously then going to produce oxygen gas, but it's going to leave water and it's going to produce its electrons. Okay, we need to balance this out. So it will be 4 OH and 2 lots of water, and therefore it would be 4 electrons. Yeah, again, as I said in the last, it's a good idea to learn that half equation for oxygen, just in case oxygen is produced at the anode in your exam question. Now we need to decide which is going to be produced at the cathode. Now the rule is, if it's more reactive than hydrogen, hydrogen is produced. If it's less reactive than hydrogen, then the metal is produced. So we look at our reactivity series, and calcium is more reactive than hydrogen. Therefore, the rule says hydrogen will be produced. Okay, so that is hydrogen plus H plus it's going to gain an electron to become hydrogen. Hydrogen doesn't exist on its own, so it would be H2. Therefore, we need 2 hydrogen ions, and therefore we need 2 electrons. So that will be the half equation at the cathode in this example. Okay, so there's a lot to go through there, so now I want you to have a go at answering these questions here. So for each of these ionic compounds, I want you to tell me which elements will be formed at the anode and which at the cathode. But do remember, they are all dissolved, okay, and therefore in solution, which means that you have to take into account the H plus and the OH minus ions as well. Okay, so what is going to be formed at the anode, produced at the anode, and what is going to be produced at the cathode. Pause the video now. Okay, so let's go through the answers. First of all, potassium chloride. Well, at the anode, which is a positive electrode, if the non-metal is a halogen, then it will be produced, and if it's not, then it won't be. Chlorine is a halogen, therefore your answer should be chlorine. For the cathode, potassium is more reactive than hydrogen, which means hydrogen gas is formed. Silver nitrate, okay, silver. So nitrate is not a halide, therefore oxygen will be produced at the anode. Silver is not more reactive than hydrogen, and therefore silver will form. Calcium fluoride. Fluorine is a halogen, so it will be produced at the anode. And calcium is more reactive than hydrogen, so hydrogen will be produced. Okay, and finally copper chloride. Chlorine is a halogen, therefore chlorine will be produced. And copper is not more reactive than hydrogen, so that means copper will be produced. Okay, so I hope you got all those right. You can now move on to test yourself in the quiz and the exam questions. We really embed your learning. And if there was anything you didn't understand, then please get into contact with one of our tutors who will be happy to help.